Good afternoon, and welcome to the special session on improving the quality of psychological science. For the last few years, there's been growing awareness and appreciation that there are certain flaws and vulnerabilities in methodologies and analytic techniques that are quite widespread in psychology. Fortunately, there's also been increasing awareness and development of corrections and alternative procedures. So we've organized a special session in which across 5 talks, 7 different experts will speak to different aspects of these methodological and statistical issues. Each speaker will be expressing his or her own views, and we'll have the standard 20-minute slot, which will, in theory, include up to 5 minutes for questions. But also, importantly, please appreciate that the last talk, which at a glance might look like I was going to speak, really is going to be a panel discussion period where all of the speakers will be available to respond to your questions. So I'd like to introduce Hal Pashler, our first speaker. Thank you, Hal.
Yeah, that's in the bill. Well, thank you very much, Steve. You know, I'm so used to talking. I've probably given 25 talks at Psychonomics, and I've always been about data, and so it's sort of strange in a way to be invited to kind of opine here, but that's what I believe is my charge, so let me go ahead and do that. So the question is, do we have a replicability crisis, and if so, what are some ideas we might be kicking around about what we might do about it all in 15 minutes? How big a problem do we have it? Well, do we have in terms of the replicability of findings reported in our journal? Well, really, the only way to find that out is to take a random sample of studies and try to repeat them. And thankfully, one of our colleagues in the social psychology field, Brian Nosek at the University of Virginia, is doing basically that. As most of you probably know, the Reproducibility Project has now many dozens of contributors helping out and is attempting to reproduce at least a large portion of the 2008 articles from Psych Science, Journal of Personality and Social Psychology, and our very own JEP-LMC. So this will be very interesting to see what happens. They're doing a very nice job with this. They're doing well-powered replications. They're contacting the original authors to make sure the results, the methods they use are appropriate, and they're posting everything online. You can track the progress of all of the people doing the work. So I think it's a wonderful project, and I think that by the way, to get a better sample, to get a better estimate, he really needs, the project needs more volunteers, and I hope people here will consider joining in that effort. But other fields of science, meanwhile, as many of you probably know, have been producing data that are well, not cautionary, data that are, in a sense, horrifying. The field of preclinical cancer research has people basically doing animal studies to validate develop potential treatments for cancer, has produced a number of hard numbers on replicability. There was a paper in Nature by Glenn Begley and Lee Ellis that Begley was the vice president for development at the Amgen Corporation, and they looked at 55 studies they hoped to follow up on, drug candidate studies, and found 11% of the results were reproducible. 89% they couldn't get them. In many cases, their efforts involved trying 50 times to get the results. He mentions in the article that they brought a number of the original academic authors in to talk to them about it. And in one case, the guy said, well, I'm not really surprised you couldn't get it. I mean, I tried it 7 times. It only worked that one time. So, you know, I know, yeah, so it's sort of funny, except it's really not funny. And Merck reported results a little better, like 20%. So this is, and the implications of this may even spread to the U.S. economy as a whole. Somebody in CNBC was quoted as saying, it drives people in industry crazy. What we are seeing is a collapse of the pharma and biotech industries, and one possibility is that academia is not providing accurate findings. It's also interesting that there's a new hedge fund is setting up to try to provide a hedging mechanism for new startup biotechs to deal with the risk that the academic work that they're trying to build on is junk. So, you know, so at least in one of our neighboring life science fields, there are some numbers already, and they're sort of disturbing. So let me just start by talking a little bit about a few thoughts that I think a lot of people have in the back of their mind who haven't been too focused on this issue, which provide a sort of false reassurance. And there's a sense of, well, we all are used to this idea of our alpha level. Maybe it's 5%, usually it's 5%. Some people, in some cases in a few journals, maybe it's 1%. And that, people think of that as, that's the risk we run of false positive results, right? So you might say, doesn't our alpha level provide like an upper bound on the rate at which we are allowing errors to accumulate in the literature? And I think statisticians have recognized for some time that John Ioannidis, now at Stanford Medical Center, has done more than anybody to expose the fact that the answer is a clear and resounding no. The likelihood that any positive published result is wrong is not the alpha level, but requires a more complex calculation, which depends on critically on two things. Power, that is the chance that a real result will be correctly identified, and prior probability, that is how many real effects there are here. So if you were doing studies in, say, genome-wide association studies where people expect that 1 in thousands of genes is going to be involved in any particular thing, the priors are going to be extremely low. So how does prior probability and power work together to determine the proportion of false results, proportion of positive results in the literature that are false? So we just made a little table. This is a sort of baby simple version of John Ioannidis' work, and if you look at it, the first row here, if you have a 10% of the effects you're looking for exist, in the sense that the null is false 10% of the time, and you have an 80% power, you'll end up that 36% of the positive results that you publish will be wrong. But what is our power level? Well, in all likelihood, people that have tried to estimate the power by doing pretty large meta-analytic samples conclude that our power is probably more in the range of 35%. So if you have a prior probability of an effect of 10% and a 35% power, now you have 56% of the results, the positive results will be wrong. In order to get a proportion of false positives that's down near the alpha level, you have to make two very optimistic assumptions. You have to assume, critically, you really have to assume that a lot of the effects you're looking for are there, that the prior probability of an effect is very high. And I think when you talk to psychologists, they say, well, look, I'm not doing exploratory epidemiology or GWAS studies. I'm being guided by my theory and testing a few hypotheses. But in fact, I think if we're honest and reflect on the number of tests we do for which, if we get a positive result, we can make up a good story, it's quite large. And the proportion of these that yield positive results is quite modest. So I think in order to assume that the proportion of false positives is going to be in the order of 5%, we'd have to assume a 75% prior probability of an effect on all the tests we do that we're prepared to analyze and report on. It's not, I don't think it's remotely plausible. So I think that the first row in this study, the first or second rows is probably more in the ballpark of the likelihood. Now this is of course where you have a single study, right? So that we're assuming now that the journal will publish a single study with a positive result. But will it? Well, in many cases it will, right? In some cases that it won't, and I think we all know something about the texture of that. But there's not necessarily any correlation between the prestige of a journal and its unwillingness to publish a single surprising result. It's also the case that a high prestige journal is more often insistent upon surprisingness. That, of course, means that this prior term is going to go down, not up. And therefore, it's very easy to imagine how the most desirable journals to publish in could easily be the ones for which the proportion of positive results that are false is actually the worst, not the best. So it's easy to see. And this is another point that John Ioannidis has made chiefly in the medical literature, that there's no evidence that better journals are really more replicable in the sense of having more reliable results. So the unavoidable conclusion, I think, is with modestly powered studies, it's very likely that more than 5% of the positive results that are made, and in many cases directly published, are going to be false positives. There's a paper I think is very important published in Psych Science last year, 2011, by Simmons, Simonson, and Nelson, called False Positive Psychology, that I think many of you have seen, which exposes the fact that this problem is greatly exacerbated by another reality of our lives, which is the reality of p-hacking. And when they speak of p-hacking, what they mean is various strategies that people follow to obtain more degrees of freedom in their data analysis than are apparent to a reader of the article. And this includes things like having additional measures that are not discussed. This includes having covariates that are introduced and discussed only if they kick the significance level of the primary variable up to the significance level. All these things will make the probability that positive published results are false higher, not lower, obviously. Okay, and this kind of reasoning led to John Ioannidis' most famous paper called Why Most Published Research Findings Are False. Okay, so it seems the conclusion is unavoidable that without some self-correction process where published results are checked and corrected, any scientific literature can and will become a junk heap full of error. So the question then has to be, well, do errors get caught and fixed? So as I think we all know, replications are extremely rare in the literature. The most recent, the article, there's a special issue of Perspectives on Psych Science on the replicability issue that just came out this month, and there's a nice review by Machel et al. that looks at the rarity of that. But this has been reviewed going back into the 70s, and it's very clear, and I think pretty obvious to all of us, that replications are quite rare in the published literature. Of course, what we really want to know is if you introduced bogus results into the literature, what is the probability that these would get caught, right? That's the number we want. So it's kind of too bad that we can't have an experiment that would look at that. But wait, we do. This gentleman, Diederik Stapel, in the social cognition field, as many of you know, probably recognize his name and his face, published more than 30 completely fraudulent made-up results over a 20-year period. So how often did these get uprooted, did these errors get caught? The answer is 0. There's some rumors that there were some people in social cognition were a little distrustful, thought that his work was a little too good to be true, but there was nothing, somebody who was out there reading the published literature would have found no reason to have any concern whatever about this. So I think that's further evidence that the self-correction, we can't assume that there's a self-correction process working away in the background that's somehow patrolling the landscape for error that we're not part of. This is, I think, the best experimental data we're going to ever get on the efficacy of our self-corrective process. Okay, so let me just, in the 5 minutes or so remaining for me, let me talk a little bit about things folks say on the other side of this issue. It's natural for people to say, well, maybe this is sort of alarmist. We've kind of known about these problems for a long time. Maybe we have some practices that are a little better than what Pashler's making it sound. And one that I've heard quite a bit, people in the social cognition field seem to place special emphasis on this idea, is that we don't do a lot of direct replications, but we do something even more exciting and better. We do conceptual replications. And by conceptual replication, they mean something which doesn't just directly duplicate an earlier published finding, but it extends it in some interesting way. And so when you get a bunch of these successful conceptual replications, they say, you know not just that the effect is real in the very narrow circumstances examined in the original study, you actually know that this has some meaning beyond the realm. So it sounds great. But let me invite you to contemplate a couple of questions. What do you do, if suppose you do, and those rare, and I know not many of us actually do this very often, but suppose you do a direct replication, okay? So you just duplicate somebody's study. Maybe you have a graduate student do this to get them started in the lab. And we can ask, does it work? And let's look at what you do as a function of the result. It seems to me when the result is yes, it works, we all feel encouraged. We think, good, he's a good student and it's a good result. We believe in the joint success of both of these. When the answer is no, it doesn't work, if we're confident that the experiment was done correctly and properly, we think, well, you know, I'm a little worried about this result, right? You're probably not absolutely convinced that it's unreplicable, but you begin to get worried about it. And you tell your colleagues about it. And it produces, it's unlikely you'll publish the result, but it's very likely it'll produce a little bit of scuttlebutt. I think we've all heard this scuttlebutt over the years about various results. And when the scuttlebutt builds up, you start to not trust certain results. Now let's ask the question, what happens when you do a conceptual replication? So if you do a conceptual replication and it works, the first thing you can do is publish it. And that's great. That's why people do conceptual replications, not direct ones, right? Because when they work, you can publish them. And if you think about it, the natural choice of a reviewer is the author of the original article that you've conceptually replicated. And we don't even need to ask what recommendation that person will have about the publication of your paper. They're right in there for you to be able to publish your paper. What if it doesn't work? Have you lost faith in the original finding to any degree? I don't think so, right? You think, well, I went one step too far away from the original procedure. So in your own mind, this does nothing to discredit the original result. You think, I shouldn't have changed so many things. So my point is, now imagine a field in which no one ever does any direct replications. They only do conceptual replications. Suppose you have some result that is fascinating, sexy result that people think, and is easy too. That attracts people to try results. Something really easy and dramatic. I won't give the examples that come to mind, but just hypothetically, something really cool and easy to do. Hundreds of people will try it. They will not try direct replications in this field that we're talking about. They will try conceptual replications, right? They'll try different things. What will happen? All the ones that work will get published, right? The ones that don't work will not even lead to a buzz of doubt. They will lead to nothing whatsoever. So my point then is